A rocket descends vertically with an acceleration given by a equal to 0.03 square root of s meters per second squared, where s is the height above the ground in meters. If the rocket starts from rest at ground level, find the time needed to reach an altitude of 85 meters. Try solving this problem yourself before watching the solution up next. This is the third example for the rectilinear motion 9-minute lecture video. The links to the other examples on this topic and the other lectures of the dynamics course are found in the description below. As explained in the lecture video, the first thing we need to notice is that the acceleration is not constant. Therefore, we cannot use any of the constant acceleration equations we derived. We do have three main kinematics relationships for variable acceleration. In this case, the acceleration and the distance are given, and we want to find the time. So technically, we don't have an equation that relates those three. And I say technically because, as shown in the main lecture video, the acceleration is indeed the second time derivative of the position, so that expression could work. In that case, we would only need to integrate twice and, of course, know a bit more about the initial conditions. In this case, since we're looking for time, it means that we will either use the first or second expression, since those have the time variable in them. What that means in turn is that we need to find the velocity. Either the velocity in terms of a, to use the second expression, or the velocity in terms of s, to use the first expression. This second option is easier. We can use the third equation first to find v in terms of s, and then plug that into the first equation to solve for t. So let's do that. We substitute a on the left. The integral limits are 0 for the lower limits, given, and s and v for the variable values. This gives us v as a function of s. Then we use the first equation, solve for t, which is what we're looking for, and substitute v. We write the limits as 0 for the lower values, and t for time and 85 for distance, since what we're looking for is the time to reach 85 meters. And we solve the integral to find that time is 60.73 seconds. If you want to check out other examples in this rectilinear motion topic, the main lecture video, or other lectures of the dynamics course and other engineering courses, make sure to check out the links in the description below. Thanks for watching.